let's talk about the heart. Have you ever really stopped to think about that incredible engine working nonstop inside your chest? Well, today we're going to pull back the curtain and really get into it. We're going to demystify the 4 key pillars that let your heart do its incredible job every single second of your life. So let's dive in. I mean, just look at this thing. This biological masterpiece beats over 100,000 times a day. It pumps thousands of gallons of blood through 60,000 miles of blood vessels. It's basically a marathon runner that never, ever gets a day off. So that's the big question, right? How does it do it? How does this little engine manage its performance so perfectly, going from a calm, resting state to an all-out sprint and back again? Well, that's the mystery we are about to solve. Okay, so here's our game plan. We're going to break down the heart's performance into 4 key pillars. But first, before we get to any of that, we need to understand the one single number that rules them all. Think about it. Before you can tune any engine, you've got to know what you're measuring, right? For the heart, there is one master metric that tells us exactly how well it's doing its main job. And that metric is called cardiac output. It's actually pretty simple. It's just the total amount of blood your heart pumps out in 1 minute. That's it. This is the bottom line, the ultimate measure of your heart's performance. And what's so cool is that it all comes down to this really simple formula. Cardiac output is just 2 things multiplied together. First, you have heart rate. That's just how fast the heart beats. And you multiply that by stroke volume, which is how much blood it pushes out with each single beat. That's the whole game. Everything we talk about from here on out is going to feed back into this one elegant equation. So let's start with the first and, the most obvious pillar, the pace, or as we call it, heart rate. How fast should this engine be running for peak performance? Now here's where it gets really interesting. Looking at this graph, you might think faster is always better, but it's not. See this inverted U shape? If the heart beats too slowly, well, obviously it's not pushing enough blood out per minute. But, and this is the key, if it beats too fast, there isn't enough time for the chambers to actually fill up with blood between beats, so the output drops again. There's a perfect sweet spot right there at the top of the curve for maximum cardiac output. This is exactly why elite athletes have lower resting heart rates. Their hearts are so efficient, they don't have to beat as fast. But when they need to, they can ramp up to just the right pace for peak performance. All right, let's move on to our second pillar. This one helps us figure out the other half of our main equation, stroke volume. And this one is all about the stretch, a concept that scientists call preload. So what is preload? It's the amount of stretch on the heart's muscle fibers right before it squeezes. Basically, it's a measure of how full the ventricle is with blood. The more blood that fills the chamber, the more the muscle fibers get stretched out. And the absolute easiest way to understand this is what I call the rubber band effect. Think about it. The more you stretch a rubber band, the more powerfully it snaps back, right? Well, the heart works in a very similar way. More stretch equals a more powerful contraction. And this isn't just a cool analogy, it's a fundamental law of physiology captured perfectly in this famous graph, the Frank-Starling curve. As you can see, as the preload, that's the stretch, on the bottom axis, goes up, the stroke volume on the side axis also goes up. It's simple, really. More blood in, more blood out. Okay, on to our third pillar. Now, if preload is all about loading the heart up with blood, afterload is about the resistance the heart has to push against to get that blood out. To put it simply, afterload is the back pressure the heart has to fight against. It's the force that the heart's main pumping chamber needs to generate just to push open the valve and send blood out to the rest of the body. A fantastic way to think about this is trying to push open a really heavy door. The resistance from that door, that's the afterload. Now, if that door gets heavier, let's say because of something like high blood pressure, you have to push a whole lot harder just to get it open. This graph here is called a pressure-volume loop, and it shows us all the work the heart does in a single beat. The key thing to notice is the width of this loop. That width is the stroke volume, how much blood gets pumped out. This black loop represents a normal, healthy workload. Now, watch what happens when we increase the afterload. That's this orange loop. The heart has to generate way more pressure, so the loop gets taller. But look, it also gets narrower, and here's the crucial point. The heart is working much, much harder to pump out less blood. This is exactly why managing high blood pressure is so incredibly important for your heart's health. So we've covered the pace, the stretch,
and the resistance. Our final pillar is all about the raw power of the engine itself, the squeeze, or what scientists call contractility.
Contractility is the heart's own built-in muscle power. You can think of it like upgrading the engine in your car. It has nothing to do with how much fuel is in the tank or how steep the hill is. It's just about the raw strength of the engine itself. But where does this raw power actually come from? Well, to see it, we have to zoom way, way down to the molecular level. This little thing is a sarcomere. It's the basic engine of the muscle cell, made of these intricate proteins that literally pull past each other to create that squeeze. So let's go back to our pressure volume loop one last time and see what this looks like. A heart with increased contractility, maybe from a rush of adrenaline, is shown by this bigger blue loop. It generates more pressure, sure, but most importantly, it ejects a much larger stroke volume. A stronger squeeze just means more blood is pumped with every single beat. So there we have it, our 4 pillars: pace, stretch, resistance, and squeeze. But here's the real magic. They don't work alone. The genius of the heart is how it conducts these 4 elements into a perfect dynamic symphony. And this brings us to a fundamental law of the whole system. The heart is an amazing pump, no doubt, but it's not a magical well. It can only pump the blood that is returned to it from the body. The entire circulatory system has to work together in perfect harmony. And this graph, which is called a ventriculo-arterial coupling graph, captures that harmony perfectly. Just think of the black curve as the heart's performance, how strongly it can pump, and think of the red line as the workload the arteries are putting on it. The system is at its most efficient right where those 2 lines meet. That's the sweet spot, where the heart's output is perfectly matched to what the body needs. This incredible, intricate balance is the absolute key to cardiovascular health, which leaves us with a final and pretty crucial question to think about. If the heart and the arteries are supposed to be this perfectly matched partnership, what happens to the entire system when one of those partners just can't hold up their end of the deal anymore?